Hello there, this is Tamina, and today I want us to look at the types of matrices or kinds of matrices that we actually encounter in Mathematics 1 for economics. So the first type of matrix that we can look at is called the square matrix. So the square matrix is simply a matrix which has the same number of rows and the same number of columns. So this implies that if it has one row, it means it will have one column. That would be the order. If it has two rows, it means it will have two columns. If it has three rows, it will have three columns. So if it's a 1 by 1 matrix, it will be like that. If it's a 2 by 2 matrix, it will be something like that. So it can be a 1 by 1, it can be a 2 by 2, it can be a 3 by 3, or it can be a 4 by 4. But the most important thing that you have to take note of is that it will have the same number of rows and columns. Then the second type of matrix that we can look at is called the row matrix. So the row matrix is simply a matrix that comprises of one row. So if you have an order row multiplied by column, it means the row will always be 1, then the column can be any number. So it can be a 1 by 1, it can be a 1 by 2, it can be a 1 by 3, it can be a 1 by 4. So this will consist of one row. So it can be something like this, or it can be like that, or it can be like that. Which now takes me to the next one, which is the column matrix. So the column matrix is just the same as the row matrix, but it is the opposite of it. So meaning that here we'll have one column instead. So if you have row times column, it means we have row times 1. So if the number of rows is 1, we have 1 times 1, or you can have 2 times 1, or you can have an order 3 times 1. So implying that you can have a matrix that looks like that, 1 by 1, right? Or a 2 by 1, or a 3 by 1. Okay, then let's now go to the next one, which is called the diagonal. So the diagonal matrix is just a matrix in which all non-diagonal elements of a matrix are equal to 0. So if you have matrix A11, it means there you have 0, there you have 0, up to the end there you'll continue having zeros. Okay, then going down, because these are not in the main diagonal, then there you have A22. Let me write it properly. So there I have A22, and then everything there would actually be 0. Then going down, everything will be 0. Then going this side, it will be A, N, N. So meaning all those elements that are part of the matrix and are not in the main diagonal always give us a 0. Let me give you an example of this. So you can have maybe 2 by 2. So that's an example. Or you can have a 3 by 3. So as long as it's not in the main diagonal, so this is the main diagonal. that means that element will be equal to 0, which then takes me to the next one, which is called the symmetric matrix, which is number 5, symmetric. Okay, so a symmetric matrix is just a matrix for which the transpose of a matrix is equal to that same matrix. All right, so if you have matrix B, it means matrix B is equals to B transpose. If that's the case, then we call that one a symmetric matrix. So this implies that if you have A12, A12 will be equal to A21. It's an example. If you have A13, A13 will be equal to A31. So apart from those elements in the major diagonal, the elements that are facing each other would actually be the same. Let me show you what I'm talking about. So suppose you have that matrix. Let's say you have A, B, and then you have C. So it means the element there, if there we have X, it means we should have X over there because these ones are what? Are facing each other. If we have Y there, it means we must have Y over there. If we have Z there, it means we must have Z over there. So this is what it implies. So if you find the transpose of this matrix, it will be the same matrix, which then takes me to the next type of matrix, which is the 60th one. We call it a singular matrix. So a singular matrix is a matrix in which the determinant of that matrix is equal to 0. Suppose you have matrix A, it means the determinant of that matrix is equal to 0. All right, which then takes me to the next one, which is number 7, non-singular. Non-singular is just the opposite of singular, and here the determinant of a matrix is not equal to 0. Okay, then we can now jump to the last type of matrix, which is the 8th one, and it's called the idempotent. All right, so this is just a type of matrix for which when multiplied it gives us the same matrix. So if you have matrix B, it means if you multiply matrix B times matrix B, it actually gives us the same matrix B. So for this type of matrix, a very good example of this matrix is an identity matrix, right? So if you have an identity matrix, if you multiply the identity matrix by itself, you'd still have the identity matrix. So we end here. Be sure to subscribe.